Hello, so today we are going to do this problem which is part of Leetcode January daily challenge. So palindrome partitioning. So we get a string S such that every substring of the partition, basically we get a string S and we want to partition it such that every substring of that partition is a palindrome. And after all of this, we want to return all the possible palindrome partitioning of S. Okay, so basically we get a string. We want to partition that string such that the parts of that partition are a palindrome each. And then we want to return overall the total number of such possible partitions, right? So for example, we have this AAB. Well, for this AAB, you could have A, B, that's one partition. And that one, each single letter is a palindrome, right? And so that's a partition where all of the strings in it are a palindrome. So we have it here. The other possible partition is AAB. Well, AA is a palindrome, B is a palindrome, so that's a valid one. Another possible palindrome is A and then AB. Well, A is a palindrome, but AB is not, so we don't include that one, right? And those are the only possible partitions, really, okay? And so we just return the possible ones. For just the single letter A, well, there is only one possible partition is A, and A is a single letter, so it's a palindrome, so we return it. Okay. Now, in terms of the constraint, we have here up to 16 for the length. So that tells you that something to the 2 to the power of 16 or even more, 3 to the power of 16 or even more should work largely fine. So, you should immediately think about using backtracking. And so yeah, let's see how we can use that. Okay, so how do we solve this? Let's see. So let's say we have the first example, right? AAB. So what we need is we want to try all the different partitions, right? And so what we can do is let's just try all of them, right? And so first we try A. Okay, and for each one of them we just want to try different length, right? So let's say here, for example, we want to try this length, and then try this length, and then try this length. Okay, and so that means here we want to try AA, so that's the second length, and then we want to try just the entire string. Obviously this one is not a palindrome, so when we reach the end, we want to check if it's a palindrome. To check if it's a palindrome, we can just check that the string is equal to its reverse. For example, in Python, you can check it like this, that it's equal to its reverse, right? So this one is not a palindrome, so we don't need to count it. And then for the other branches, so this one we already used 1. So what's the remaining? So here we should, for each call, we should pass the remaining string because we want to still use the rest of the partition. So here the remaining part is AB, and here the remaining part is just B, and here the remaining part now is empty. And so we are done here. But here AB, again, each time we try all the possible length, right? So here we can do A only, or we can do AB, right? So if we do A or AB, okay, so if we do A, what's remaining? Just B. Here, nothing is remaining. But the problem is that here, for this one, AB is not a palindrome, so we don't account for this. But here A is a palindrome, so B, right? And so A is a palindrome, A is a palindrome, B is a palindrome. Here it's an empty list, so we just check B is a palindrome, right? So that means that this here is a valid palindrome, right? So A, so basically it's going to be something like A, and then B, okay? And now let's just continue here. So we have AA, and then the remaining is B. And so we'd have to choose B here. And remaining is empty. And B is a palindrome, and so this is valid. And so we have this as well as a valid palindrome. And so palindrome partition, and so we would have, which is AA, and then B, right? And those are and we stop because there is no other options to do. Right? And so you can see here, the two things we need to pass are for our state, the two things that we need to pass are the, let me write them down, the remaining portion of the string, and that's here, for example, and the path so far. So we want to know at this point what were the previous values that we added that were palindromes. So, for example, when we reach this B here, we want to have the path contain AA. And when we reach this B here, for example, we want the path to be A, right? So that when we add B at the end, we can just return the rest, right? And for example, here we want to say that it's just AAB, right? So we want both the remaining portion of the string and we want the path as the state for our, let's call it helper function or backtracking function, whatever you want. Okay, and now the thing, how do we like do this in code? How do we do this choices thing? Well, as I said here, it's just trying different lengths, right? So we want to try just this length, and then try this length, right? So you can think of it as the length of the portion of the substring that we want to take. And how do we represent that? Well, that's just for the remaining string, that's just for I in the range. The minimal length needs to be 1, right? We have to take at least one character. We can't just go with empty, right? And so it has to be from 1 to the length of the string, right? Pretty simple. So the length of the remainder plus 1. Okay, the remaining of portion of the string, right? We want to just, each time we do it just on the remaining. So this was the initial remaining, but here we do it on just the remaining, which is AB, right? And that's the main idea. And so here for each one of them, we just call helper function. But what should be the new remaining part that we send? Well, for the remaining part, the first thing to pay attention to is that we don't want to call the recursive function. For example, let's say in a case like this here where we have AB. Maybe this is not the right thing, but let's say we had a string like A, B, C, A, like this. When we are at the state where we have ABC, right? Let's say maybe, I don't know, AB, the ABC may not be the right thing here. Let's say we have X, AB, X, A. So when we are at AB, X, A here, right? We know this is not a palindrome, right? And so no need to continue, stop here. No need to continue to this A, and let's say there may be other things here. No need to continue, stop here. And so here, before continuing, we want to check if it's a palindrome. If the portion that we are taking is a palindrome. So if the remaining for I, which is the portion we are taking, is a palindrome, then we want to take it, right? And then we can recurse and just call on the helper function for the remaining again after taking up to I, which is the length that we are taking. And that's just from I going forward. And then what's the path? The path is just the previous path plus what we are just taking, which is the remainder with a portion of a remainder of length K, of length I, right? So that's just like this, okay? And that's exactly what we are doing here. So for example, let's say for first A, so we take A, right, length 1, and so what should we pass as the remaining? Well, we should first check if A is a palindrome. If it is, then we take then we pass the rest as the next call, the remainder of the next call. What is the rest? The rest is just AB, and that's exactly what we pass here. And then what is the path? Well, the path should be just whatever was the previous path, which was empty in this case here, plus what we just took. What we just took is A, and so that's why here, for this one here, we pass it with the path here, for example, is going to be just A, right? And then when we go down here, for the next time we call it, then what will happen is that we will go here, the length, we take the length is 1, and then we take the remainder up to I, and that's just A itself, right? And so we recurse on the rest, which is with B as the remainder, and then path, we just add this A, and that's why we pass this path here. Okay. So that's pretty much it, the idea of the backtracking here. I hope the solution was, this explanation was clear, but if it's not for you, just draw this decision tree again and think about this concept of length. Okay. Yeah, so pretty much let's use this this concept and let's implement it. Okay, so now let's implement what we saw in the overview. So what do we need here? So what we need first is we need to have our helper function that we spoke about. So the state is going to be the remaining portion of the string and the path so far. And then we want to try all the different lengths, right? And so we just go for the range, and minimum length is 1, right? You can take an empty string up to the length of the remaining portion of the string, right? And so what's so basically this means we are taking rem I and recursing on the rest, which is basically just remainder from I to the end, right? So this would be the length we are taking. But before taking it, we want to make sure it's a palindrome. So we need to define a function to check if it's a palindrome, right? And so this would be checking if this is what we want to take. If it's a palindrome, then we can just continue recursing. But if it's not, because every partition has to be a palindrome, so there is no use in continuing if it's not, right? And so here, what is the rest? The rest is just the remaining from I to the end. Now, what is the path? The path is just the path we had before plus what we just took, which is this portion, right? And so to add it to the path, we just need to mark it as a list like this. Okay, and now what we need to do is just do our base case here. What is our base case? Well, when the string, there is no more remaining characters, right? So that means we are done. And so here, what do we want to do? We want to add it to a result list. So let's just have our result list here. And we are going to add, what do we want to add? Well, the path, right? The path is the partition that has all components being palindromes, right? And so we want to add the path here and return. And then we want to call our recursive function, of course. So we call it initially with the entire string, and the path is initially empty. Okay, and then at the end we return all of them, and that should be it. So pretty straightforward there once you have the concept. So let's reset, run this. Yeah, we didn't define the function that tells us that a string is a palindrome, right? For the checking here, so I'll just define that. So we give it a string, and a palindrome is just a string where the string itself is equal to its reverse, right? And so we could just use that to our advantage. You can use like a 2-pointer thing where you check from both sides, the start and the end, if you wish to. But yeah, this is just quicker in Python. Just check the string is equal to its reverse, and that means it's a palindrome. And that looks good. Let's submit. And it passes our test cases. Yeah, so I think this is pretty much it for this problem. Pretty straightforward backtracking. You just need to think about what are the choices, and here the choices are trying different lengths and proceeding only if the substring we are looking at is a palindrome. Yeah, so please like and subscribe and consider joining my Patreon, and see you on the next one.